Hi, this is Pete Singer. I'm the editor of Semiconductor Digest, and I'm here at SEMICON West 2024. I'm talking to Frank Powell, who's the business development manager for Marposs, and they've got a lot of new products here at the show. And we're going to get into detail on each of those in just a minute. But Frank, I wanted to ask you, can you tell us a little bit about just kind of the general philosophy and direction of your company?
Okay, Marposs. Well, Marposs was founded by a gentleman named Mario Posati. Marposs.
Okay.
In 1952, and the original out of in Bologna, Italy. He was obviously Italian gentleman, and his first product was an electronic in-process gauge to control a grinding machine, and from that, Marposs has grown to today. We're around in every major country in the world with products from still maintaining the original in-process gauges for grinding, but through the machine tool system, through post-process control systems, automatic gauging machines, automatic systems for quality control, systems for integration as we evolved into the EV business with applications for hairpin measurements of motors, roll-to-roll applications for battery production and so on, leak test systems for battery packs and everything else, and now we're growing even more into the semiconductor with some companies that we've acquired over the years. One of the featured here is a California company from Solarius that we acquired last year, and moving into that, expanding our business beyond traditional manufacturing that we started in.
Okay, I see.
And our whole company is based upon a philosophy of customer service. Our direction is the customer comes first. We satisfy you. We're not trying to get you to satisfy us.
Okay. Well, that's a good philosophy.
Yeah.
And so Solarius you acquired last year. Can you tell us a little bit more about what?
Yeah, Solarius is a company that was started 25 years ago, and their business has been primarily in semiconductor, some in biomedical, some in aerospace, but extremely high quality control systems, process control systems, using non-contact sensors. So either chromatic confocal point sensors, cameras, line sensors, laser sensors from various manufacturers. Their strength is really in the mechanical setup, because they don't produce their own sensors, they purchase them, so they're commercially available. So if you have one that a particular source you prefer, they will use it if it fits the application.
Okay.
But their strength is the software in the system and the mechanical design of the systems. They build everything's off of a standard architecture, but their software is one of the few softwares out there that not only can control the machine motion for inspecting, but also can do the inspection, collect the data, and report the quality of the product. What we have to show here, we have different types of products that are used in the processing of semiconductors, and quite honestly, a lot of different products. On this end, the first one we can look at here are machine control systems. So this system that we show in here is an in-process gauge that can go on a back grinder, on a CMP machine, or even on lapping machines, depending on what you want to do. And what do I mean by in-process gauge? An in-process gauge, in the terms of Marposs, is a device that monitors the stock removal of the part in real time and tells the machine when the part has reached certain size criteria, even down to final size. So in what we have as an example here is an in-process gauge for like a back grinder, where we have, because most machines have multiple chucks, we use a contact gauge on a reference surface on the chuck to adjust for the variation in the heights of each chuck as it comes under it. And then we have, in this case, a confocal gauge, which is a contactless gauge, measuring the stock removal of the part in real time. This is a system that Marposs has been supplying for quite a few years now in a lot of applications when wafer thickness gets down below 100 microns in thickness, where you can't touch it with a contact gauge. So between the two, we can control the thickness of the part as it's being ground and tell the machine when to stop. What this display here is, displays as a system that uses acoustic sounds in order to tell when a contact between an abrasive wheel and the part, or the abrasive wheel and the dressing mechanism on a grinding machine come in contact. We can detect through sound the moment the first grain of the grinding wheel touches the object that it's headed towards. What this does is it reduces cycle time because you don't have to spend a lot of time grinding air to get to the part, and it also prevents hard crashes in case you have overstock parts. So it's a system that's used for that. It also monitors dressing. If you have any kind of form in the wheel, if you have a special form, we can monitor it during the dressing process to guarantee that the entire face of the wheel has been dressed properly. Another application that's used in the production of semiconductors is in the sawing process of the ingot. We can put an acoustic sensor in, and we can have it on we put a reference bar right near one of the rollers for the wire, and if the wire snaps on the saw, we can detect it and shut it down before it cause great damage to the structure of the machine and the structure of the part. So it's a safety mechanism to protect the machine and increase productivity. What we're showing here is some chromatic confocal sensors. In 2019, Marposs acquired a company, Steel. Steel was the inventor of chromatic confocal sensors that are used for inspecting many things. In the case of semiconductors, where they're used for the checking of total thickness variation, TTV. We look at edge conditions. We can look at for cracks and surface roughness of the sensor and so on. And this illustrates various types of sensors, families of sensors we have, from very small pencil probe type sensors from the old gauging days, all the way up to large view sensors that have high angles of incidence that we can measure, and large areas of measuring very quick in real time. What we're showing here is a product that's produced by Solarius, the group that we acquired last year. At this time, on their workstation, this is what's referred to as the Viking station. It uses a chromatic confocal point sensor, and in this case, we're measuring the surface roughness of this wafer. The system is completely programmable as far as looking at measurements through the common software, the Solarius software, which does not only the movement of the stages for the measurement, but also acquires the measurement system, does the calculations, and produces the output if what the part condition is, as well if it's an acceptable or non-acceptable part. It's one of the few systems out there that has all-in-one in one software location. All the part program that you may have, if you have this device, can be stored. Each recipe is stored and can be recalled from the software. So it's a very intuitive using software, very user-friendly, and a speaking system not very complex at all. What we're showing here is another platform from our Solarius group that's called Polaris. And in this case, it uses, the beauty of the Solarius equipment is the fact that the software that's on the Viking, the Polaris, and other machines is the same software. Obviously, sections that are used out of the software for an application that are required. So it doesn't have everything, but everything's put together where it's modular, where you can bring in those things for either a very simple roughness measurement all the way up to complex measurements. So in the case of the Polaris, this is using chromatic confocal microscopy. So it's a much higher resolution system. In this case, we're measuring the integrity of the die that's on the circuit itself, or the wafer itself. So it's a very high resolution inspection, very detailed of the wafers that's on there, higher than what you would have for like something simple with a chromatic confocal system. And the last thing that we're showing here at the show is a new product from our Solarius group. This is a probe card inspection machine that's built on the standard AOP 900 frame. So in this case, we're inspecting the probe card that would be used to test each die on a wafer before it's diced, and it's inspecting to make sure the quality of the needles are where they need to be, so we can find out if there's something wrong with it and it can be rejected or repaired or whatever without taking and putting it on a machine and wasting time and possibly damaging an expensive circuit. Once again, the software controlling the system is the same software that goes across the board. So when you have these Solarius systems in your plant for different functions, it's simple enough for your operators to move from one application to another and recognize how the system works and be comfortable with it without having to learn totally different systems to function properly. So as I said, we're introducing this probe card machine as a brand new product at this show this year. And to get into the details, it's best to have the expert explain it. Tendra is our technical expert on the system, and he can get into the details on the theory of operation and what it can do. Tendra, please.
Thank you, Frank. So what we have here is the Solarius solution to probe card inspection. So again, this is a non-destructive test, and the benefits of the software platform is it does this automated analysis. We can look at each individual needle, and we can look at a summary of the needle bank, all quite comfortably in a nice compact, concise format. Again, a common software platform, so we can move between the confocal microscope to the probe card inspection system to the Viking, all under the same umbrellas. Quite good for ease of use for the operator.
All right, thank you, Frank. Thanks for your time today. That was very interesting.
All right, Pete, thanks for stopping by. Appreciate your time.